So, high energy DC systems. We're going to spend some time talking about what that is. You've heard me say it a couple of times already. My definition is a high energy DC system is when you have an alternator head that's 3 or 4 kilowatts or larger. We at Wakespeed have deployed tens of thousands of these systems. By and large, our systems go with anywhere from 5 to 8 or 9 kilowatt alternator heads. That amount to generate power greatly increases your ability, combined with lithium-ion batteries, the ability to recharge them very, very quickly. That's one of the key values of the high-energy DC systems. To be blunt, generators are going out. Many of our installs either don't have generators or they don't use them, and we'll talk about that in a little bit here on some of the real-world examples. Other characteristics of high-energy DC systems is large storage battery, typically lithium-ion, and although AGM is actually not a bad alternative, to be blunt, I would say 95% of our installs that we see are with the lithium-ion energy storage systems. Large inverters and large alternators, again, all but eliminates the need for AC generation. So why high energy DC systems? If we look at the marine, and I'm going to mention the RV quite a bit, and you guys are actually fortunate because you're getting this training, and I know as you go out into the world, there is a massive demand in the RV side. Just as a little sidelight, if we go back 20, 30 years ago, the entire RV industry, as you may know, looked to the marine world to understand what to do for DC systems. If you want to know how to install an alternator, go do what the marine guys do, because they figured it all out. That's actually flipped. The bigger demand these days is in the RV world. And because they don't have that fundamental decades-long experience with DC charging, nobody in the RV industry knows what happens if you go and grab that big master switch and turn it off while the vessel's running. I'm sure everyone in the marine world does. You'll get float tested real quick. There is a big demand and a gap in the marine world for skill sets. I'm just putting out an advertisement for you in that respect. So what is happening that's driving all this? Well, like everything in the world, everything's getting bigger and better. We have more electrical demands in marine systems and RV systems. People don't want to leave their comforts. We drove before we got onto the ferry here. We were over there in Coopville, drove through the little park. Big giant fifth wheeler. He had his dish little satellite thing out. He had his little internet satellite thing out. Now, I'm thinking to myself, that's really not uncommon. These people, nobody wants to leave the comforts of home. They want to take it all with them. They want the big refrigerators, the ice makers, they want the TVs, they want everything. And that's driving big demands. Now, we're seeing additional benefits of these high energy DC systems, such as cooling. Cooling was probably the biggest motivator, again, in the RV world. These little Sprinter vans, they want to have an air conditioner on. And they don't want to listen to a generator running all night to run the air conditioner. So you've got the high energy DC systems that are able to support the AC. But that's opening up other aspects. We're finding barbecues, we're finding hobs, we're finding in-floor heating. When I fitted out my personal vessel, I tried to remove propane. Just because, one less fuel system to worry about and have to refill the tanks. I worked my hardest. I found we solved the problem for heating. We didn't care about air conditioning up here. There was a solution for the hob. You could get one. What was the stumbling block for me is, try as I might, I could never find a diesel-fired barbecue. So I had to bite the bullet and leave propane on the vessel. But there are now electric barbecues. They'll run off 48 volts or off 110. That's really a lot of part of what's driving these high energy systems. And the value to the customer, this is what they like. And this is how I actually started this thing myself. My personal trip, maybe 10, 15 years ago, is I don't want to listen to generators. You go out into the world to be peaceful, and you want to sip your cup of coffee in the morning without having to listen to a generator. Or you have your sundowner without listening to a generator. That's a primary customer, that's a second primary customer driver. In addition to all the electric loads, quality of life. And then you can get into aspects of efficiencies and lower costs for maintenance. You don't need an entirely separate engine driving a generator. There's a lot of other secondary values. And as you guys are talking to customers, these are things you'll want to keep in mind. they'll have questions, and you guys, hopefully you'll get a little bit of insight and be able to steer customers with values of why would you want to do this, and is this a good fit for you? I'll also kind of take a step back here. I often get asked questions, should I do X to a boat? My first question is, well, how are you using it? I'm sure you've all experienced 9 times out of 10, people don't have an answer for that. They just say, well, I read about this in a glossy magazine. It sounds cool. I want X. It's like, how are you going to use your vessel? You need to walk down that path to find out if this is a good fit. Increasingly, high energy DC systems are, but it's not universal. You know, you got somebody who doesn't have refrigeration and doesn't have, I mean, there's a lot of people who, they're perfectly fine with a little old golf cart battery. Perfectly good system, nothing wrong with it. So I'm sure you all know that, but that's just kind of some of the life lessons that we have learned. And we also hear numerous times from customers saying, I want to do X because it sounds good. And then when you talk through it with them, you find out it's maybe not a good fit. And they're not willing to take all the steps necessary to do it safe as a system design. Okay, is there any questions at this point about what a high energy system would be and maybe the components that go into it? We're going to cover a little bit more in depth on this. I just want to make sure I'm not going over stuff that you really already have a good handle on. Okay. All right, I'm getting a thumbs up from Kevin. All right, one example of a high energy D system, large house storage bank. This is the legacy 12, in this particular case is a 48 volt install. Legacy 12 volt install, you still have a lot of legacy 12 volt equipment, or 24 volts sometimes you run across in the marine environment. We've got a alternator charging system controlled by Wakespeed. You've got your large inverters, you've got a bunch of solar panels. This is very representative. And also notice the servo at the top for the monitoring. That's another expectation customers are having more and more. So this is take away or put in, very representative of what a high energy system is. And we've covered a little bit about this. How does it work? You need to optimize for your loads. Typically what we find, especially with these split voltage systems, and I'll also put a little advertorial in. I don't know what percentage it is. I'm looking at my partner Rick, but I'd say 60% of our deployments are 48 volts.
Yeah, I'd say so. You know, on the marine side, maybe 10%.
Yeah.
But in general, about 60%.
Yeah. Marine hasn't really crossed the 48 volt world yet. And part of the reason is, to be candid, they got 24 volts, so they don't quite need it. If you start with the 12 volt world, it's all but impossible to do this. 24 volts, we have a number of deployments to do it, but 48 volts brings a number of good advantages. So the demands for electrical loads, largely air conditioning is what's driving these type of systems. You need to consider not just what the static loads are, but the nominal loads, the little small guys, the refrigerators, the lights. Those guys are still at 12 volts, or in the marine world, 24 volts. And we don't see those changing anytime soon. So as you move forward in this, unless you have a pure 24 volt install, which does happen, you are very likely going to find mixed systems. And that induces some complexity that has to be considered how to solve it. So one of the first things you want to do is start with what are the loads and what voltage system is best applied. High wattage loads, high energy loads, move to 48 volts. Here, do it directly if you can, or through inverters to do 110 AC. All the legacy stuff, the light bulbs, frankly, light bulbs probably won't go to 48 volts, and there's reasons for it. They'll probably, 12 volts will be around for a very, very long time. You need to consider not just the static loads, but also the surges. So if we look at sizing generators, a disadvantage of generators is you have to size them not for the ongoing load, but for the peak and the startup load. So if you've got an air conditioning system that draws 4 kilowatts nominally, you may have to have an 8 kilowatt generator just to do the startup surge. And there's also aspects of what the actual quality of the AC power coming out of the generator that comes into play here. But the bottom line is, with generators, you have to size for the surge. When you're sizing with a high energy DC system, you have to size your inverters for the surge. That still has to happen. But one of the big advantages of the DC systems is the efficiencies. When you size an AC generator, an 8K generator that has to run at either 1800 or 3600 RPMs because of frequency demands, it is very, very lightly loaded, right? And that produces some efficiencies, which we'll cover in the next slide. But when doing high energy DC systems, what you want to do is you want to look at the surge loads. That's going to tell you what your inverters are. You want to look at how long this person wants to be able to run without running a generator or the engine. That's going to tell you how big your battery bank is. I mean, pretty intuitive, but you'd be really surprised how many people don't even take that simple step when looking at stuff. Okay. I talked about AC generator efficiency. Yes, sir?
I got to stop right there just for a second.
Yeah.
Can you help us, where is the best place to acquire this surge load information on our products? Because many products today, as you well know, do not give us that information on the box or in the directions. You have to really do a lot of digging.
So my stock answer is always contact the manufacturer. But as you pointed out, that often doesn't help. In the real world, the thing that's the most critical is anything with a motor. And there's something known as lock rotor amps. If you can't find a spec, and I'm going to look for confirmation because I'm going out on a limb here, I would say if this thing says it draws 10 amps, just plan on 20 amp surge. Does that?
I think that's a pretty good rule of thumb. Just we're going to double whatever that amperage is for the first few.
If they're not going to tell it to you, yeah. Now, the other aspect of that is also what the inverter can take. And this is another, I'll just be frank with you, this is where you have to just try it and learn. Because manufacturers on all sides of every coin lie. I'm sorry, they publish specifications for you to study. On my personal vessel, I've got an AC compressor that I use for the air horn as well as to drive a hookah system. It specifies what the lock rotor is and it specifies what the surge is. I also have an inverter that matches that requirement. It doesn't work. I had an inverter from one brand that worked great until it stopped working. Then I went to the glossy magazines and bought an inverter that was highly recommended and it met the specifications. It doesn't work, so I had to go out and buy a larger inverter. So unfortunately, there is no definitive way to answer that particular question. I'm sorry. If you're going air on the high side, like everything in the world, you don't want to be running them at 90% of their capacity, 100%. Try to, oversize, go one size bigger. And that's how I've gotten through. Like on my Anchor, for example, I actually went 2 sizes bigger, and I sleep well at night. So do the same thing when sizing, okay? I want to talk a little bit about fuel efficiency. My wife and I, we retired early. We sold everything and we moved on to old Monk wooden trawler. During that time frame, we had the opportunity to move back to Minnesota to the family farm with my wife's folks as they were taking care of their aspects of life. And I got time to spend time on the farm. I actually have driven the combine, which I guess is a massive honor because most farmers, when they plant seeds, they want to drive that combine. Well, Dean, who now owns the family farm, it's a dairy farm. He said, you're more likely to scare the cows than you are the combine. So you do the combine, and he did the cows. So that's how I got to drive a combine. But one of the things I noticed in there's a reason why tractors have got like 96 gears. And that's because every single engine in the world has, and this is a very simplified view, every engine in the world has an RPM, horsepower, and efficiency curve associated with it. And the idea is you want to be operating up at that 100%, 110% point. You want brake fuel consumption, BFC. You want the most output, usable energy output from your engine for every ounce of fuel you put in. That's why tractors have got 96 gears. Because when you're going through hundreds of gallons of fuel a day, the difference between gear number 82 and 83 can make a difference. And here's the problem with AC generators. When you fully load them, this is just an example, when you fully load them up at that blue star point, you're doing pretty good. You're on a curve that we're just going to call 100%. Now, if it turns out that you could reduce the load on an AC generator a bit and come back to this point here, right, you'd actually get better efficiency. Have you ever heard this phrase that you want to size everything for peak torque? It actually turns out that that little 110% happens to kind of coincide with the peak torque of an engine on most engines. So the point being that you want to be largely on the output curve. Now with AC generators, when you only have them, say, half loaded, when you're only doing 50% of the output, you're over here where the red star is. And guess what? You're now down at 75% efficiency. You're burning, if you do, you see changes, you're burning more than 25% more fuel. And actually, most AC generators are even loaded even lower. So they'll end up burning 2 or 3 times the amount of fuel necessary for the typical load that they're presented with versus if you had them fully loaded. And this is where a DC system comes into play, because an AC generator, unless you have one of the fancy inverter ones, which is actually a DC generator with electronics behind it, has the inverter built into the generator, the AC generators have to run at this fixed speed. You have no choice because you have to maintain the hertz. Whereas with a DC system, if this is all the power you need, well, we'll just slow the engine speed down and we'll get back up into that 100%, 150% efficiency. A lot of people don't think about this. This is something that isn't, it takes quite a bit of brain power to get behind this and kind of do the math. And I know every time I look at it, I have to puzzle quite a bit. But again, I'm going to come back to my personal vessel. I built a DC generator and I did the math and I figured that I burn 1/3 the amount of fuel to run my DC generator because it varies its speed and it's always on this high efficiency curve point versus if I'd use an AC generator. So when you're talking to customers about high energy DC systems, this is actually a good point to bring out. Now, there is an unfortunate corollary to this that if you're running a big giant engine, even at idle, just to drive an 8 kW head, well, guess what? You're not up on the curve. However, if you have your vessel underway or your van is underway, it's already well up on that curve. You know, the reason cars have got 8-speed transmissions now is so they can get back up on that curve. So when you apply that extra 8 kW load to a vehicle that's in motion, you're going to be doing very, very efficient fuel burn rate. Is there any questions on this? Have you guys seen this before? Have you even thought about it? Have you been exposed to this before? Okay. Yes, sir.
Back to the earlier comment you made about the sizing of generators,
Yeah.
the inrush current of all the conceivable loads.
Yeah.
It just seems like we've got a built-in problem here with the fixed RPM of the generator,
Yep.
the power curve of any internal combustion engine that's converting chemical energy into mechanical energy, the goal being universally fuel efficiency.
Yeah.
And so where I'm sort of sensing you're headed with this is that when given a choice in a marine application with high loads, a lot of systems, a lot of demand, between a generator and all of its maintenance and all of its engineered in limitations, that the higher capacity DC system is preferred.
It's a great value, and obviously we have a vested in. Sorry, I grabbed my mic. That guy just went. We obviously have a vested interest in this because we're a key player in this space. But when you look at how things were done 40, 50 years ago, and fuel cost 20 cents a gallon, nobody really cared, right? But fuel ain't 20 cents a gallon now. And that's just one aspect that makes a 50, 60-year-old architecture less desirable, the fuel efficiency. AC generators go to burn, I'll bet 2 to 2.5 times more fuel than a comparable DC generator system would, hands down, just because of this. Now you've got all the maintenance issues associated with a lightly loaded engine and low cylinder compression and glazing in there. And then you tie in the cost associated with just buying it. You'll often find that putting in a high energy DC system is less expensive than putting in an AC generator. And you've got the ongoing maintenance cost with it, right? So
Engineering inefficiencies, like no one's going to have control. You can say, oh, well, I've done a load assessment on it, and I've interviewed you about your use pattern, boat owner number 1 or whatever. And yeah, based on that data, I can, from an educated place, choose the optimal generator, but I can't overcome the inefficiency.
you'll never overcome that. And it's because it's a fixed RPM. Now, having said all that, I remember early on, there was a slipmate of mine down in Portland that would come up every summer. He had a big 65-footer and, you know, one of the classic boats that you'd find running the generator, if not 3 in the morning, 3 in the evening, sometimes 7:24. What he did is he got one of those little Honda generators. And it's an AC generator, but think about it. It's really a DC generator with an inverter, all built in. He'd get one of those little Honda guys, he'd throw it on a swim step platform and bungee cord it on so it didn't go in the water, he hoped, and run an extension cord, and he actually bought a little 20-amp charger. And he hooked that up to his house battery, and he just had that thing purring along all the time. My wife and I, we actually did that for a little while, and then we kind of figured out that we were getting killed by the exhaust because it's a generator bungee cord to the swim step, right? Which was a horrible idea. But you're exactly right. You will never, this is a physics thing. You can't get past this. And then when we add all the other potential values, this is why we're seeing shifts. And you're going to hear me talk a lot about the RV industry because by and large, most of our sales have been in that space. It just has been. They've had a forcing function. These little Sprinter vans, they ain't got a lot of room in them. So there's a benefit to not dedicating that space. So that was an additional motivator. But let's look at some examples that don't have that room constraint. This is probably one of our first installs of a high energy DC system. Used MG Energy is the brand. Yes, MG Energy is the brand. Yes, MG Energy is the brand. Really large. I mean, this is like 6-figure installs, right? I mean, when you've got a boat that costs a lot more than 6 figures, you don't mind 6 figures into the boat. But really, really interesting person. They take this vessel north of the Arctic Circle. Rick, I mean, you know a little bit more.
Actually, there was a really interesting article in Passage Maker magazine about this boat. It was written by Steve D'Antonio. Yeah, this boat has gone further north than just about any other, individually owned recreational vessel anywhere. This has spent more time in places that nobody else goes, and that's part of the critical nature of getting the electrical system correct, because there just aren't technicians north of the North Pole.
There's no beaver planes that show up to bring you spare parts, right? My wife and I had an opportunity to spend a few days with them on their vessel, and it was just wonderful to see the photographs that they had. Just, if you're the type of guy or gal, sorry, if you're the type of person who likes to go cruising, I mean, this has got to be like, wow. He actually has done a couple of the Northwest Passages as well. Things are opening up. The thing that I like about this is this quote from him. He now has to look for reasons to run his generator. He's got a large battery bank, fairly large, 2,200 amp hours at 24 volts. That's a pretty good sized battery bank. He doesn't ever have to run his generator. They'll pull up anchor and they'll move, and in 2 hours, they've recovered all of their energy that they use. But his challenge is that he runs out of water. and he was angry with me. They ran out of water because he didn't size his inverters large enough to run his water maker. So that's why he has to run this generator. But here is a perfect example of a high energy DC system. This has a single engine, single screw. They put 2 alternators on the same engine with 1 Wakespeed controller managing it. And he's one of our first examples. This is another example. And again, this was with MG Energy System. This is, we think, the first recreational trawler, large power vessel, not a sailboat, but a large power vessel that made a passage to and from Hawaii without ever running their generator. This is a vessel that had the washer dryer, had the HVAC, had the water maker running, had the refrigerators, the air conditioners, the stoves, everything running off of AC power. They never started the generator. And what's really interesting about this one is this had 2 battery banks. This is actually a value that Wakespeed has that we'll cover in a bit. We have the ability to aggregate multiple battery banks. During this passage, the battery bank in the bow, a cell went sideways. And that BMS took that battery bank offline. But because of the communication of the Wakespeed recognized that, readjusted the entire system's parameters, and carried on the voyage with just the battery and the lazarette. The only reason the operator knew about this, because nothing changed in terms of their operations, they didn't have to turn off their refrigerator, they didn't have to stop taking the jacuzzi baths. The only reason he knew about it is this guy was curious, he did his little cell phone app, and he noticed that forward battery was offline. This is one of the key values of these high energy systems, and I'm going to use the word system a lot, because it's a very, very important concept. A little bit, another example showcasing some of Wakespeed's capabilities. This particular system had, again, a primary engine with 2 alternators on it. Oh, yes, ma'am. Sorry.
Yeah. So before you began your talk, I thought that Wakespeed was just a kind of external regulator. I'm now gathering that it is not that.
It's a lot more than that, yeah.
Could you, as you're getting into some of these details about the value to the vessel, and I don't doubt that you'll elaborate later, but can you just give like a quick overview of what this system is?
Sure. So just to cover your question, yes, we are definitely going to go into detail on this. The Wakespeed is different than traditional external alternator regulators in 2 ways. 2 primary ways. There's a number, but the 2 big ones are we're more than a voltage regulator. We actually monitor and manage battery voltage, battery current, we're a current regulator, alternator temperature, we're a temperature regulator. We can also manage system load. So when you put an 8 kW head on an engine, there may not be enough guts in that engine at certain RPM, so we can actually pull back so that you don't overload. So we take into account the battery subsystem, we take into account the alternator, and we take into account the chassis. Those are 3 primary, or those are kind of the big differentiator of the Wakespeed. It's in the middle of all of this, and that's why we become kind of I want to say a critical component, because we're touching all these things, we're taking all this information in and making decisions, all right? By the way, that'll come up again later, because we're also the blame for anything that goes wrong, which we'll cover that in a bit. Does that answer your question? Okay, thank you. All right, another example, this particular vessel, this used, the reason why I put this one in is that this vessel is, again, a Nordhaven. We've done quite a few large Nordhaven installs, as you can tell. This one was lithium-ion batteries. We, again, had 2 alternators on the main, but then also on the wing, they put a large alternator on the wing. Now, what's interesting about this is some of the capabilities that the Wakespeed has the ability to prioritize. So when we're looking at how to charge the battery, we can prioritize who should work harder. In this case, they said, work the wing harder. So if they happen to be running the wing engine as a DC generator, they want to load that engine up. Remember we went back to the fuel efficiency curves? They want to put as much load on that guy. So we'll back off the mains and we'll load up the wing. That's one value that was demonstrated on this vessel. Another value that was demonstrated on this vessel is that wing engine also drove their primary hydraulic pump. And this particular vessel had hydraulic bow and stern thrusters. Every time they hit those thrusters, the engine load would go to like 90 or 100%. Well, if you're pulling out 70% of the engine load through the alternator, and then you hit a thruster and you're now all of a sudden at 170%, you can guess what's going to happen. The Wakespeed regulator is able to detect that. And when they hit those thrusters, we see the engine load go up, and we would back off the alternator so you didn't overload the engine. We'll get into that, how you go about doing that, probably tomorrow. But the reason why I put these three examples is because they showcase each one of them in a different way, the values of high energy DC systems and the values of the Wakespeed alternator regulator. You have more efficiency, better quality of life. I'm annoyed because I have to find reasons to run my generator, right? You've got auto fail-safe and redundancy. I'm a licensed captain. When we went down to Reno, because they don't know anything about boats, they're learning. Rick and I are teaching them. You know, they're kind of wondering, well, why are you guys so careful? It's like, because there is no AAA, and because if things catch on fire, you can't just step out of your vehicle, right? So we are hypersensitive. I am hypersensitive about failure modes. And it reflects in the product we have built and reflects in the design choices we have made. So we've got redundancies that automatically will come into play and not require human intervention, which is notoriously unreliable to recover from issues. And then we've also got examples of this whole prioritization and how do you make your system work well. Again, and I still have so many people call up and doing installs where they've mounted 5 or 6 toggle switches on their dash because they want to be able to do this, this, and this, this. That's fine if you want to do that. You can, but you don't have to, because carbon-based control units, people, are horribly unreliable. So that's why I've showcased these three, because it illustrates different aspects of the Wakespeed alternator regulator and what values it can bring to the table, providing it's installed and configured correctly. Now, they're not all these giant 6-figure installs. This is an example of a vessel I just visited here a few weeks ago up in Roche Harbor at the Celine Rendezvous. They had done an install. I'm sorry, I'm proofreading this to make sure I didn't leave anything in there. You guys are the first ones to see a slide deck, so if there's anything goofy, I apologize. They had done an install with a modest lithium iron phosphate battery. They don't have air conditioning. They have to have heat, and they run a diesel, fired heater for that. And their great benefit is they used to have to run the AC generator underway because the ship's load underway exceeded the output of the engines. It just couldn't keep up. They also ran the generator every day at anchor. And now, neither of those things they have to do. So they're very happy. So their primary improvement was quality of life. They said, it's great, I don't have to listen to that bloody generator anymore. And just so you know how much I hate generators, my cruising style is we'd be heading north by now, and if we saw people, we'd go more north, and I carry a bag of potatoes, because I found there are a number of boats that actually have got a problem. They leak. And they usually leak for a couple hours every evening. And I found if with a potato, you've picked the right size one, or I'll just go over and plug the hole for them, because I don't want their boat leaking, right? And it solves that particular issue. Sometime later they have other issues, but at least I've solved that one, right? And I hope you understand what I'm saying, and no, I don't really do that. Except that whole aspect that when I see people, I go further north. Yes, I do that. Now, one last example I'm going to give you is a very, very modest install. This is a 60-year-old wooden trawler, happens to have, or had, 1,400 amp hours of lead acid batteries. They were forklift batteries. Could sit at anchor for 5 days. Didn't have air conditioning, modest refrigeration use. We had supplemented with solar panels, a couple of inverters in there. This is actually my personal vessel. This is actually where the Wakespeed all started out some 15 years ago, the Wakespeed technology. This is where I learned what works and what doesn't work. my wife and I, and maybe we'll talk a bit more about this in a bit, we actually retired early and sold everything, and that's all we owned. And our cruising lifestyle, we came in, stayed in Friday Harbor for the winter, when sometime October, November, when it turned rainy, and supported the coffee shops there. And then in the spring, as soon as I could pry my wife off the dock, we'd head north. And she actually found that if she cleaned the dock lines, she could get an extra 2 or 3 weeks out of me, because she likes coffee, right? But nonetheless, we were away from the dock 8 months plus out of the year. That was our cruising lifestyle. We'd come in once a month for provisioning, and all the rest of the time we were self-sufficient. So high energy, early example of a high energy DC system. It still makes sense today with lead acid batteries, although the Wakespeed predominantly gets deployed with lithium ion.